So year 10, we are looking at conservation of energy today. So this is lesson 2 of this topic. So first of all, what I want you to do is write down the title, and your task is to see if you can remember the name of the 9 different energy stores that we talked about in lesson 1. So write those down in your book and then click to see if you are correct. So we have electrical, nuclear, chemical, light, sound, gravitational potential energy, kinetic, thermal energy, also known as heat, and obviously our elastic potential energy. So did you get all of those right? If not, complete the ones you missed. So you now have 7 questions to answer. These are based on last lesson. Let's do a recap and see what you can remember. So in your books, pause the video and answer these 7 questions. So year 10, here are the answers to the questions. You've got gravitational potential energy, chemical energy, and obviously that is converted by the process in every single cell in your body via respiration. The equation for that is glucose plus oxygen, and that's converted to carbon dioxide and water. Obviously, there is some heat involved there given off. We then have kinetic energy is our movement. We have elastic energy. And then finally, in our speakers, some of the energy is wasted as heat from the moving parts in that speaker. And then in our car, we have our petrol, our crude oil, which is converted into petrol. That's our chemical energy. And then the transfer is into kinetic energy. Obviously, the moving parts of the engine will also create some heat, and some is converted into sound as well. So that is our wasted energy in our cars, which obviously we also use to heat up our car, especially in winter. And some of that chemical energy will also be used in electrical energy for our lights and things like that, for our radios in our car. All sorts of things like that are extras, but the main transfer is from chemical energy from the petrol into the movement energy, which is kinetic. So the law of conservation of energy, can you remember what this is? So a little tip here, we know what conservation is. You might think of conservation of wildlife or conservation of a woods. What does that mean when we talk about energy? So you probably managed to work this out, that the law of conservation means that energy cannot be destroyed or created. It can only be transferred from one form of energy to another. So the total energy in a system remains constant. If you haven't written that down, write that down in your own words. So here we have a plane taking off. I want you to do a flow chart of the energies involved here. So what does the energy start as? What is it converted to? What it is transferred to? So you need to read the information below, and then you are going to make a flow chart, which goes from box to box to box to box of all the different energy transfers that are involved when a plane takes off. So you should have worked out that the plane uses fuel. Again, this will be some type of airplane fuel from crude oil. That chemical energy is converted into kinetic energy. As the plane goes up into the sky, that kinetic energy is converted into gravitational potential energy. And then as it is flying, some of that energy is then lost to the environment through heat and sound. And then obviously as it returns back to the ground, that kinetic and gravitational potential energy will be converted back into friction, drag, sound, heat as it lands on the ground. So we have 2 types of energy systems. One is closed and one is open. In a closed system, it is a system in which no energy transfers take place out of or into the energy stores. So basically, like our plane taking off, some of the energy is lost in the environment. Actually, in a closed system, everything is contained within. So nothing is lost and nothing is gained. In an open system, that would be like our car or our plane or even our body. Our energy is lost to the environment. And therefore, the energy out will be less than the energy in. Can you please make a note of the two systems in your books? So if we were in school, we would be doing an experiment with a clamp stand, elastic band, and some weights on the end to do a bungee jump, basically. So this would show us the energy transfers and what actually goes on in a bungee jump. So what I want you to do, first of all, using the equipment on your screen, is to write a method to show the energy transfers during a bungee jump, and just use the equipment in the diagram. You are allowed to add extra masses, and then I will show you my method. So you would set up the equipment as shown in the diagram. You would choose a fixed point at the top of the clamp stand, connect your weights to a rubber band, and then you would drop them. You would then record the lowest point and the highest point, and then you'd repeat those steps a number of times and write down your results. So we would expect to get a set of results that look like this. So as you increase the load or you increase the mass, you would increase the extension of the bungee jump, and you'd also increase the rebound of your bungee jump back up again. So it would go lower and then it would rebound higher. So in all experiments, especially as teachers in school, we do a risk assessment. So we would look at the hazards involved in this experiment, and then what is the risk or the likelihood of that happening to us. And then we would take safety measures to do that. So I want you to jot down at least one or two hazards in this experiment. What's the chances of that happening, the risk, and then how would you avoid that? What safety measures would you take? So the basic hazards in this experiment is something falling over or falling onto you, anything sharp springing back or recoiling into you or your skin or your eyes. So obviously everything would need to be weighted down, and you would need to be wearing goggles. So just add any information that you've missed there. So what would you conclude from that experiment about the energy transfers? Think about what happens at the top, what happens at the bottom, what happens to the elastic. See if you can jot a very, very brief conclusion down. So basically, at the top, you have a high amount of gravitational potential energy. As the jumper jumps or the mass drops, that energy is converted into kinetic energy. As the gravitational potential energy lowers and the kinetic energy rises, that rope will begin to tighten and stretch. So it is then turned into elastic potential energy. Eventually, the jumper will come to a stop at the bottom, and the kinetic energy will be transferred completely into elastic energy. When it reaches the bottom, obviously the person or the weight is going to bounce back up again, and that elastic energy is going to return to kinetic energy, which obviously returns to gravitational potential energy as the bungee jumper goes back up into the air. And obviously that process continues to repeat until the bungee jumper comes to a halt. So just pick out the key energy transfers from this information, or add to your own information for your final conclusion about your bungee jump experiment. Okay, so if you still have time left, we have some questions here, especially for our G1s and G2s, H1s and H2s, and our G3 and G4. I expect you to do some of these questions in your books, and then what I would like you to do is email in your answers so we can see how hard you've been working.